In this work, we visualize the NASA Mars lander dataset. The Mars lander was originally simulated on Summit at the Oak Ridge National Laboratories and is a large computational fluid dynamics dataset. The simulation grid of this dataset consists of almost 3 billion finite elements and was simulated on over 500 GPUs. Those 3 billion elements are distributed among those 500 GPUs so that each GPU only holds a part of the whole dataset. What's special for us here is that we don't only have the whole dataset, but we actually have the parts as they were originally simulated. For the visualization, this allows us to replay the whole simulation on our own cluster and on our own GPUs as though we were simulating the dataset ourselves. This allows us to perform what is called an in situ visualization, where you watch the simulation while it is running and visualize some of its data without copying the data to a workstation. Instead, the visualization uses the exact same GPUs and processors that are also used by the simulation. To implement the visualization, we use a ray tracing framework that is developed at the University of Cologne. That framework builds a bounding volume hierarchy over the finite elements. This bounding volume hierarchy allows us to send optical rays into the finite elements. By tracing more rays from the point of intersection to the light sources, we can determine if those finite elements are visible or not. Ray tracing is a global illumination technique, and that means that finite elements can cast reflections onto other finite elements. Using the emerging ANARI standard by Kronos, we can integrate our ray tracer using plugin mechanisms into standard visualization tools such as ParaView, Covise, or Visit. Covise and OpenCover are also used to operate the cave virtual environment at the University of Cologne. So we hope that we'll eventually be able to simulate on RAMSES, visualize the simulation result in situ, and then present the results in our cave in virtual reality.